Example 10. Verify that the functions f and g are inverses of each other by showing that f of g of x is equal to x and that g of f of x is equal to x. Here, f of x is equal to 5x minus 4, and g of x is equal to x plus 4 over 5. All right, so if you think back to page 2, where we were looking at the characteristics of a function and its inverse, the last thing on the list here, number 6, told us a cool property about composition, the composition of a function and its inverse. So if you read number 6, remember, if you compose a function and its inverse in either order, so if you do the inverse composed with the original function, or if you do the original function composed with the inverse, you switch the inside and outside functions. No matter which way you compose the functions, you should get the same thing, and that quantity is x. That is a way of proving that two functions are inverses of each other. Okay, so that's what you're being asked to do here in example 10. Okay, you're giving two functions and you're sort of verifying that they're inverse functions. Okay, and we're doing it through composition. Okay, another way that you can do this problem without composition, like if you wanted to prove that g is the inverse of f and that f is the inverse of g, you can just take one of the functions and find the inverse, okay, and make sure you get the other function. Okay, inverses are unique. So basically, if you take one of the functions and find the inverse function and it turns out to be the other function, that sort of proves that, you know, the functions are inverse functions. Okay, but here we're going to do it through composition. So let's get started. We have to do the composition both directions. It's not good enough to just do one direction. You have to compose them in both directions and make sure you get x as the result in both situations. Okay, so here we're going to start with the first way. We're going to do f of g of x. So here f is the outside function, g is the inside function. So we're plugging g into f. Okay, so remember how I do this. I'm going to write down the outside function, which is f. So I'm going to write down 5x minus 4 because that's what I'm plugging into. And then everywhere I see an x, so I'm going to circle my x, I'm going to replace it with g of x, which is x plus 4 over 5. Okay, so this is going to give me 5 times, remember the circle, you want to think of that as parentheses, 5 times the quantity x plus 4 all over 5, okay, minus 4. Okay, and now we need to simplify. Okay, so this is basically going to be 5 times the quantity x plus 4 over 5 minus 4, okay, and then here, if you think of this as 5 over 1, okay, you see a 5 in the top and a 5 in the bottom. Those guys cancel. So this whole fraction, okay, that you'll leave you with a 1 in the denominator. 5 goes into 5 one time, 5 goes into 5 one time. So you're going to end up, if you multiply across the top, you're going to get 1 times x plus 4. That's just x plus 4. And the bottom is going to be 1 times 1, so the fraction essentially goes away. You're left with x plus 4. Don't forget the minus 4 that's hanging out, okay, out to the side. Okay, so then you're left with x plus 4 minus 4. The 4's cancel, and you're left with x. Okay, so we verified the first direction. If you do f of g of x, you compose them, and yes, you do get x. Okay, so now we need to check the other direction. Okay, so we need to do g of f of x. Okay, so we're just switching the inside and outside functions. So now we're plugging f into g. Okay, so we need to, if we compose this direction and we also get x, this is going to prove that these two functions are inverses of each other. Okay, all right, so since g is my outside function, I'm going to write down g of x. That's x plus 4 all over 5. And then we're plugging in f of x. So everywhere I see an x, I'm going to circle my x. I am replacing it with f of x. That's 5x minus 4. All right, so let's simplify. Okay, in the numerator, we're going to have 5x minus 4. That's in red. And then don't forget the plus 4. Okay, that's going to be the new numerator. Okay, the bottom is still going to have 5. Okay, clean up the top. In the numerator, you see the -4 and the +4. Those two guys cancel, and that's going to leave you with 5x in the numerator. You still have 5 in the denominator, okay? And then you see a 5 in the top and a 5 in the bottom. 5 divided by 5, those guys cancel, and that leaves you with just x, okay? So we're done. Okay, we have done the composition in both directions, both f of g of x and g of f of x. Both directions gave us the same thing, namely x. Okay, so this proves that f and g are inverses. And that's it. Okay, so again, just to kind of recap, this is one way that you can verify that two functions are inverses. If you compose them in either direction, you should get x. Okay, and then another way to prove that two functions are inverses, which we did not do here, but we talked about, is if you just simply take one of the functions and find its inverse function. If you get the other function, that is sufficient for proving that the two functions are inverses as well.